Regular listeners will know I'm a bit of a fan of Apache Kafka. I think it's a great system for storing data, for processing it, and just for shipping it between different parts of an organization at scale. It's great if moving data from A to B is your job, and so often it is. And in software terms, Kafka's a very mature project. It's been around for over a decade. It's got a large, stable user base. It's got a large, stable committer base who are actively moving it forwards. And it's a backbone piece of infrastructure for a lot of big companies. So in one sense, Kafka's arrived. And I got really intrigued when I heard about a company that took a look at Apache Kafka and said, let's keep the protocols the same, but we'll do a complete rewrite of the implementation in C++. That's a bold move for any company. Why? What's their motivation? What's so important that you want to take on a project of that size and maturity? And what are you actually rewriting? Are you rewriting the entire stack or just parts of it? Are you being completely compatible, or are you deciding to make tasteful breaking changes? And most of all, what do you think you can do differently this time around, now the whole industry is older and wiser? Lots of questions to ask, so today we're talking to Christina Lin of Redpanda. Redpanda are that upstart company taking on an Apache staple. And I've seen in the wild, I've seen people using a mixture of Kafka and Redpanda in their tech teams. So clearly Redpanda have added something to the software world. Let's see what they've got to add to the conversation. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Christina Lin. Christina Lin, thanks for joining us.
Hi, Chris. How are you?
I'm very well. I'm glad to see you here. How are you doing?
It's my pleasure to be here. I'm doing great.
Great. I've got many questions for you because we share kind of share a background. You are currently head of developer relations for Redpanda.
Yes.
I was heavily into developer relations for a Kafka-related company. So we're on two sides of the same wall, right?
I love that. I guess we can have a really good conversation then.
Yeah. So let's start off with the big issue, which is, okay, Redpanda, Kafka, similar space, but why do you even want to be in this space?
I can kind of talk a little bit about it from my perspective as my career evolved. So I was doing a lot of Java programming back in the days, right? So, and then I started a position in an insurance company. And at the time, we're doing a lot of like SOA and a lot of work. And, when it's SOA, it's a lot of like system integrations and services integrations. And that is when I get into we started using a lot of like IBM solutions, but it becomes very clumsy. So, and that's when I started doing a lot of like Apache Camel. So that's how I get into the Camel space. So I was doing a lot of data integration, and the time I also was working for JBoss, and that was why I got into Red Hat doing a lot of JBoss work. Plus, I got to do a lot of my like very like lovely Camel project as well with the Camel crew and all that. So it was great, a lot of system integrations, and I kind of see why like a lot of the need of having data integrated. And we were using messaging queue at the back, right, for SOA integrations and all that. So messaging queue I was heavily using messaging queues from IBM MQ to, ActiveMQs and RabbitMQs and all that kind of stuff. And that fits in naturally. When Kafka came out, we were like, awesome, this is a lot faster, streaming services for us to kind of quickly get data in and out. Like it was able to get a lot of IO throughputs for that. So we love that. And so that's why I kind of work. And Camel was kind of introducing Kafka as part of as ecosystem. So that's why I got into Kafka and kind of using that as the backbone for system integrations to pass through to build that, microservices backbones and stuff like that. And then when I was looking for other solutions, and I was kind of looking into Quarkus, and we were kind of introducing, it was kind of at the time where we were using Quarkus, and I saw this like really tiny container because Quarkus was introducing this like really tiny container, so people doesn't have to spin up the whole like backend services. Developer can quickly run things. And I saw this Redpanda solution. I was like, what is this thing? Why is it? Because at the time, Kafka still needs zookeepers and all that brokers and all that. I was like, why do I don't need all that kind of stuff to actually start developing? And so that's why I started looking into Redpanda, and that's why I got into this space of Kafka and Redpanda. I hope that answers your question, but that's how I learned about the whole data thing. And I really like the data aspect of things. So I'm slowly getting back into the data engineering and learn how data engineers were using the streaming platforms. And I think there's a lot of potentials for future development as well. So that's kind of how I got in that.
Yeah, that's a story. The shape of a story I've heard a lot. It starts with desperately wanting to ship data between different systems and then grows, right?
Yep.
And often, as much as we talk about real-time data, it's just sheer the effort of connecting data from A to B that is the killer use case.
Yes.
So, from what I know about Redpanda, like you talk about smaller container sizes. That's one of their big pictures, right? Compared to Apache Kafka, Redpanda is kind of chasing the size, performance, deployment, ease, benefits.
Yeah, I think
right?
when Redpanda first got out, it was very well known for its performance and the size of its container and how much resource it needs to adopt, right? So I think that's why people start to adopt Redpanda, is just because of the simplicities and the size of it needs to execute the similar stuff, right? So that's kind of how I see it and how people first got into it.
But it's a curious road they've taken to get there. To look at something like Kafka and say, I'm assuming this is how it originated. You look at something like Kafka and you say, I would like this to be smaller and faster. I'll rewrite the whole thing in C++.
Right. I think, this question should go directly to our CEO, our founder, because he actually wrote the entire project. But when I asked him about this question, because I think he was very well into the low latency streaming RPC at the time when he was working for Concord, and he was doing a lot of like low latency streaming development at the time. So for him, I think when he was starting to develop this application, he was facing a lot of unpredictabilities and, a lot of the things when they have higher traffic throughputs, things crash. Or when you get a machine that's able to handle the load, it is super expensive. So I think as a developer, he's trying to figure out a way to kind of become more efficient on processing the data and getting data streamed. So that's why I think he started to look into Apache Kafka, because he was solving that problem. And then he was able to find a way to kind of develop things. And I think he didn't first start with C++. I actually asked him, like, why did you choose C++? And he was like, no, actually, I started with Rust.
Okay.
Right. And then I think at the time when he was developing things, the Rust wasn't mature enough. I guess it is now, but at the time it wasn't. So he has to go back to his favorite C++. He was developing a lot of C++ program already. And I think it was one of the framework in C++ that actually solved a lot of problems. In C++, that actually solve a lot of problems for us, right? It's the C star framework. The
C star.
Yeah, C star framework is a very unique one because it allows a lot of the asynchronous programming inside your computer. Because if you think about your computer is it consists of CPU, and CPU is split into many cores, right?
Yeah.
And how a lot of the programs were developed. They were developed in a way that a lot of things were taken. Were kind of use operating system to kind of make things a lot more flexible. So it loses a lot of the control over how the CPU works and how the memory works, right? And I think Kafka was developed in Java. I think Java is a great program. I am a Java developer for 2 decades now. I love Java, and I think it's a great program. But I still think there's a benefit of different tools for different purpose. And I think in terms of controlling the hardwares, C++ is a better language for that because of how you can kind of utilize cores. So instead of relying all the memory management for JVMs, relying on your operating system to do context switching for your CPUs, the C star framework allows us to control everything. So so we can kind of allocate the amount of memory per core. So this core will control this part of a memory. And that fits great with the Kafka nature because, remember how Kafka works? It has a lot of partitions. And then you're writing logs into each partitions. So basically, we can assign multiple partitions to a single core. And this core will just take care of all the things in this partition. And this would avoid context switching because I think a lot of people has this misunderstanding of what is causing the latencies of writing data into my system, right? A lot of people think the problem was the disk, but it is not anymore because we're not in a very old disk space where we have one single, little pinhead we're trying to kind of write data into.
Yeah, we're no longer spinning a magnetic disk.
Exactly. We're not spinning anymore. We're working with SSDs with NVMe architectures, meaning that I can write multiple times into the disk and having all this data allocated in our disk in very different place because how the file structure works as, the XFS, sorry about my pronunciation, allows you to parallelly grab your data quickly from your disk and then put it back to the memory. So in terms of that, your disk is no longer the problem. Your CPU time is the problem. And being able to utilize CPU allows us to quickly grab the data and provide it to the users and vice versa, doing the same thing to quickly put it back into the storage. And that's why I make Redpanda super fast with that C star. And I think Alex saw that, and that's why he implemented everything with the C star framework. And that's why it's the secret behind why Redpanda is super fast in terms of performances and the lower latencies, low tail latencies, and all that kind of stuff.
Okay, what kind of year are we talking about for this? Whole.
I think it was 3-4 years ago, maybe.
Really, that recently?
Yeah.
Okay. I know some people will be disappointed that you didn't stick with Rust 3 or 4 years ago, but
I think it was just at the time, maybe a little bit earlier. I didn't exactly know when Alex was implementing Rust. Maybe it's a little bit earlier, but yeah, this is from what I know.
Okay, fair enough. Then there's the question of okay, if you've decided you're going to rewrite Kafka, do you know why it's decided to stick to the exact protocol? Because you can, as I understand it, you can drop in Redpanda and largely have your writers and readers, your producers and consumers, transparently work with either.
Yeah, it's just because I think the number of users we don't want because I think from Ring Zero, which is the broker side, and then you've got the client side, right? So I think when Alex wants to do it, he wants to kind of also support that ecosystem for the Kafka users. So that's why we choose to adapt the Kafka APIs instead of inventing our own. So we can provide that faster Ring Zero experience, but also providing that for the existing Kafka users. So that's something that we try to solve. It's similar. I always put that as an analogy of cars, right? Car is a very good thing where you can hop on it, driving it, and then you can get to the places. But how you build a car is different. So over the times, we have really nice diesel cars, petrol cars, and then now we have electronic cars. I think it's just how you build the cars a little bit different, but the way you drive it, we want the user to have the same experiences and kind of how things are built. But internally, how it's done it is up to the car manufacturer, right? So similar.
Yeah, no matter how they implement it, you've got pretty much the same user interface on a car, right?
Exactly. Yes.
Except I can never find where the heated mirrors are on mine. They're always in the wrong place.
Yes.
Okay, I can see that that you want to keep the same protocol to reach the same user space.
Right, exactly.
Right?
Yes.
Where do you draw the lines around that? How much of wider Kafka do you want to rewrite in C++? Is it just the broker? Are you targeting Kafka Connect next, for instance? What's the scope of the project?
Currently, I think what we're going towards is more on the Ring Zero experience, right? So not actually the connector itself, but the actual broker we want to kind of make, because Redpanda is a very small company compared to the large community out there for Kafka, and even Confluent is a multi-million-dollar company where they have a lot of money to throw around. But Redpanda is very small, so we want to make sure that we invest things in the right place. So we want to make sure that we give people the best experience from how we can kind of control. So we focus on the Ring Zero experience on that. So we don't expect to expand a lot outside of the connectors. We expect to work with the connectors. We work with the community. So, for example, FriendsGo, which is the Go library for connecting to Kafka, was developed by one of our engineers. He was kind of donating to the community and kind of show people how this is done, and we were talking to them. We try not to be the enemy of the community. We try to be friends because we all work in the same we're trying to make this space better, right? So giving people more choices, this is what I think we should be and how the community should work all together. So I think we should so to answer your questions, I think for us it's more focusing on the broker itself. So things on top of that, I think we added the Redpanda console, which allows us to kind of have a very nice GUI interface for developers, for them to see what's going on inside. I know there's a lot of projects out there that can do the same thing, but I think it's for us just to kind of make it more smooth transition from people to see what's going on, and maybe use that on top of even Kafka as well, and all that kind of stuff. That's where we're focusing on right now.
Diplomatically, I would say there's plenty of room for more development in the Kafka user interface space.
Yeah, I think there's different opinion sparks different ideas, and I think that's a good energy to the community. Not just if you all have people speaking the same thing, then you're not going to have innovations.
Yeah. Do you know, it reminds me, I was at another company talking to some people that worked there last year, and they used Kafka in production, but all their developers locally were using Redpanda. That's the first time I heard about Redpanda, and I want to ask you, why do you think they would have that divide?
I think we're seeing the same thing. Like from me, from the community side, I see the same thing. I see a lot of developers were kind of using Redpanda internally as a development, and they have like Kafka because their operations staff kind of decided on using Kafka. I think it's just the easiness of how to use Redpanda and how to start it. I think adopting Kafka as a beginner, I don't think it's the most easiest thing. First, you have to understand Java, and a lot of the people I talk to right now are Python developers, Go developers, Rust developers. For them, like Java is intimidating. And then to download the package, and then at the time you still have to start the Zookeeper, and then you start the broker. It takes for them a lot of. It's harder to get around. So for them to start Redpanda as one single binary, they start it up and they can start working. I think for them it's easier, and then the footprint is a lot smaller compared to what is taking up. So I think that's one they want to do. Even Quarkus, well, I think I mentioned that the first time I heard about it is Quarkus, and when they were doing the dev suite, it was when the dev suite is a way that for developers to not care about setting up the environment that they need to work on. It would just work for them, and the dev suites has Redpanda in there, speaking that it's because when I actually talked to the people that adopted, they say it's smaller in footprint, it's easier kind of to get it started. So I think that's why. And I was working on a project, a test container. I don't know if you heard about test containers, but I think they're
a little bit
pretty well used in Spring Boot community, right? Because they were using that for testing and local development as well. I've seen their download rate for compared to Kafka and Redpanda. I think Redpanda is pretty good in terms of usage. People can just download it and use that as their internal development platform, so they don't have to get all that things started. So I think that also contribute to that.
I got to push you a bit on that, because that landscape must be changing a bit, where Kafka's moving away from having a separate consensus protocol of Zookeeper to it being eternal. Meanwhile, you've got Redpanda. I'm guessing if you want to do something really interesting with it, you end up wanting to bring in Kafka Connect or maybe Kafka Streams. Do you think that single binary argument is still valid, or is it eroding?
I think it's still valid, right? I mean, for me, the developers I talk to doesn't really use the connect that much. They are using Python to develop and connect to Kafka. So I don't see that happening. And Kafka Streams is just an API you put on top of the broker, whatever broker that you're using. So I don't think that's going to be a determinant issue for using Kafka at all, right? And Kafka Connect, and since I am a Camel developer, a very long time Camel developers, I write my own Camel components. So for me, that is independent. Whatever I put underneath the hood doesn't really matter. I'm writing the integration on the top. So for me, I don't think that's a big issue for that. And especially now, I'm starting to hear less and less about Kafka streams. I think more people are going to Flink.
There's been a lot of push to
Yeah,
Flink lately.
For the past 2 years, it's all about Flink. Every time when I do a Flink course, people just come in and they want to hear about Flink, right? So I think it's the push of Flink that kind of added benefit to us because you're kind of free from embedding a particular solution for that streaming services, right? So I don't think that's a big problem for us.
So from that point of view, presumably you're looking at Flink as a good thing competitively.
Yeah,
Because it
it's great.
frees you up from having to compete with like higher level infrastructure stuff.
Exactly, and I think,
I can see that.
Yeah, and I think a lot of people were adopting Flink because the SQL nature, and then I think KSQL was introduced. It was a good idea, but I don't think it was. There were problems with KSQL, right? So, I think Flink kind of solves that extra layers problem.
I'm going to try and keep my knowledge in this space and my biases out of it, but I wanted KSQL to succeed more than it seems to have done. Let's just say that. Right. I liked it a lot. I would have liked to have seen it continue to a glorious future that I don't think is going to happen now, sadly.
Yeah.
But this raises the question of how are you seeing people use Redpanda in production? I mean, a lot of Python developers. You can tell us a bit about OCaml. When you talk to users, what are they doing with all this?
So currently, our major customer base are more performance oriented. That's the beginning. Like if you look into most of our customer base right now, I'm seeing a lot of users that they were having problems with Kafka, basically with the performances and the number of machines they need to start up, and a lot of management problems. And I think it was the past 2 or 3 years, I think, building up all that. So they were kind of switching to Redpanda, and that's the most of the use case I see for now. But now I'm starting to see a lot more since we added the BYOC offering from cloud. So I think we kind of convert a lot of the people that wanted to have a quick cluster running on their own cloud account. We kind of have that. And so I'm starting to see a lot more less experienced Kafka. Before it was all very experienced like Kafka users. So we got really hard question to solve, like how do I get number of performances, like latency numbers, up for less hardware usage and all that. So that was a lot of problems we had to solve. But now we're seeing a lot more, like in the mid journey range of people where they're trying to get into Kafka, but they don't know how to do it. And kind of we help them to do all that kind of stuff.
Okay, so you're seeing more people just casually moving over from presumably starting their journey still with Kafka?
I think most of them, when they come to us, they would know a little bit about Kafka. Well, I'd see 1 or 2 exceptions, but they're very little, right? Compared to the majority of the people I see, they still know Kafka, but they want to experiment with other things. So I think they're just looking for the second opinion and different options for these type of users.
My loyalty here is to the ideas and the architectures rather than specific implementation. So I've got no skin in the game on that one. Okay, so when you said you have a Go client, this is another thing I wanted to look into. So you said people are intimidated by Java, but this is C++. I can't believe the general programmer is less or more intimidated by C++ than Java. You've got Go as a main client. How are people interacting with Redpanda language-wise, and how are you supporting that? What development are you doing in that world?
For us, I think we kind of just that France Go project was kind of donated as a open source project, right? So anybody wants to use that, even connecting it to Kafka, we're happy to
Okay.
do so, right? So that's something that we do. But our main focus are still in the broker space, where we're developing a lot of like auto rebalancing, leadership rebalancing, and all that kind of stuff. And then we are also, I don't know, we're also working on something called WASM. I don't know if you heard about our WASM project.
WebAssembly, yeah.
Yes, our WebAssembly project is something that we're working on. So we're trying to, because we've seen this thing where people are building, very simple data pipelines where they're only doing very simple transformation stuff or validations or very simple, data conversion, masking, and it needs to have a lot of data ping pong because you need to get it out from a socket and then put it back in, right? So this is something that people do. And we were thinking if we can have this in the broker, let the broker do all the processing. So before it reads out from the memory, does its thing, and then put it back in the memory. So there's no huge round trip between the networks and all that. That would make things a lot faster. So can we have this built into the broker and without having external things going on? And the idea of bringing WebAssembly was because WebAssembly is a very flexible engine. We can use that to compile different type of languages, like Rust with Go and with Java, with Python. So developers can freely choose whatever language they want to use for this very simple, transformation pipelines and put that in the broker. So I think externally, the Flink services will be outside of your broker, which is doing a lot of like traditional complex event processing and a lot of like time window based processing. Internally with these, very simple stateless, transformations, everything can be done in the broker level. So you don't have to do a lot of, data transfer in the networks. And we see a lot of networking costs occurred for, people using a lot of partitions. You can see replication all around. So if we can kind of eliminate that, that would help a lot. So
I could see that for like, this is just splitting a comma separated string into a list. You would want to do that in a more lightweight way than Flink, right?
Yes, exactly.
Yeah, I can see that makes sense. Are you in any way enforcing a boundary for what you consider simple or complex there?
Yes. So we do. So we think that, if it's something that you need to kind of hold its state, that is a complex one. So for things that you don't need to you don't have to keep it state, then it's a simple stuff, right? Because the reason is when we deploy the data pipeline into the broker, there's several brokers in your cluster. So Redpanda needs to kind of copy all your pipelines across the broker in order to get all things done inside its own little machine, right? So so keeping the state of where the pipeline is going to be a very huge workload, and you kind of have to know all the status, like all the other worker status. So we don't want to do that. We want to make sure everything is simple and easy. So we want to sure. So if it's stateless, it's simple, then it is. But again, like the reason we're doing that is because there's a lot of people they're not utilizing their entire hardware. But if you already have a very busy broker that's taking up 100% of your CPU time, it is probably not a good idea. So you probably need a couple of different nodes for that. So it all depending on situations, but I think it's going to eliminate a lot of like network costs and latencies and all that.
Yeah, I can see, provided it's contained, that's going to you always want to separate storage and compute, but once you've separated them, you want them to be really close. Right?
Exactly, right?
They want to be sitting right next to each other, but still separate.
Exactly. You want to like the fastest time, uptime of that. So
okay, I could happily dive into the guts of how that works in implementing the WASM runtime engine.
It's still work in progress for us right now. We're still developing it. Currently, we got the Go engine running for WASM, but we're still working on the Python and Java part of the mainly the Python because majority of our users are Python users. But then we still have Java users we want to do. But I think that is something that we're working on simply because the way that they handle memory is a little bit freely compared to what Go
Yeah.
does. So how we write the assembly engine to make it work for internally with the C++ with our thread core architecture, we need time to actually get that thing work more efficiently. We can just plug that in, but that is gonna cause us performance issues. We don't want to do that. So we want to make sure that we kind of see we can manage all this the memory usage and like how we treat all the core, how it's used inside your computer.
Yeah,
so that's something that we're working on.
You've got that classic sandboxing problem when you let users execute arbitrary code on your machine. You've got arbitrary problems, right?
Yes, that's right.
Yeah. Okay.
So that's something that we're working on. And we're also working on other things like, also not just the where the broker part, but also the cloud services part. We're trying to launch our serverless solutions, which is like something for developers so they can kind of spin up a topic where if they wanted to do that. So with the more to actually get more exposure to developers, because now they most of them were just running in locally, but we wanted to have that presence in the cloud as well, other than BYOC. I think BYOC kind of does a better for us, but I think we want to include it in that footprint as well.
That connects to something else I saw about Redpanda, because if you're doing bring your own cloud, right? I want to know if I bring my own cloud, what you offer on that. And also there's something about you using native object storage in Redpanda, which I think is related here. I wanted to ask you about.
Okay. Yeah, that'll be good. Because I was actually, I talk about this in current this year. I'm in current BYOC. And actually some of the people that was managing the Confluent Cloud came to me and said, this is an awesome idea. And they were the back engineers. And like they were like, we should do that. I was like, no, don't. But I think it was the way that we did it is we don't want it to be direct management. We don't want like it's a user or from Redpanda to go directly into the cloud because it's not safe. And we don't want it to be very manual because that's going to cost us a lot. So we want it to be automated, safe. So the way we did it is we had an agent, which is a very small VM that gets deployed into the customer's cloud. So this enclosure is customer cloud. We don't have access to it. The customer needs to install the agent in their cloud, and we'll be controlling everything from outside. But we don't go directly into the cloud. We have the agent to pull requests from our controller plane and then does things on their own, does all automated things on the cloud. So everything is isolated. And with this particular data plan, even when things goes wrong with the control planes or whatever we want to do with Redpanda, your things still stay intact because you actually have your own little ecosystem of your own cluster. You're working with the cluster, you're working with everything. And then the controller plane is just kind of doing all the updates and all the patchings, all that kind of stuff for you. So basically we just issue a bunch of commands and an agent just pulls it and it just does that on your own like cloud and just kind of fix things for you there.
Okay, so if something goes wrong with that link, you can't change anything, but nothing stops running.
Yeah, everything
that makes sense.
Running there.
Yeah, I can totally see that argument.
Yeah, and I think for people, what they like about it most is working inside their VPC because that VPC is a cost, right? For the traffic goes in and out. So I think what people like about it is like, I can put that in my VPC.
Yeah, that makes sense. So again, there seems to be a kind of cultural focus on the developer experience side. Is that something you're deliberately focusing on as kind of a competitive advantage? Or is it just when you're smaller, that's easier to do?
I think we put a lot of effort in terms of user experiences. There's a user experience group internally inside our company where we think about user experience a lot, right? So when we push out a new feature, we want to think about how easy is that from a user's perspective? How can I make that easy for developers? We constantly make changes. I think from what you're saying, if the company is smaller, it's easier. Yes, of course, it's always easier because you don't have to go through 300 meetings in order to get one feature change, right?
Yeah.
So definitely, yes, that's going to contribute to it. But I think it's the way that we design our product. I think it's kind of make it. So, for instance, the data rebalancing and that can be done automatically. So, Redpanda will automatically detect what's going on inside each partitions. If it gets too busy within one node, it will shift things around automatically for you without you
Oh,
knowing.
okay. Tell me more about that. I didn't know about that.
So yeah, of course. So we do like automatic data rebalancing because the way that we do things, it's very different. So Kafka claims that they do KRAFT, but KRAFT only applies to the controller side of the story. So where it used to do things in Zookeeper, they move it to KRAFT. But underneath the hood, KRAFT is doing whatever Zookeeper was doing. And then you still got your petition, your ISRs and all that, doing all the replications and all that. But Redpanda underneath the hood itself, we don't have a actual controller of things. All the petitions forms a raft ring. So you can see a lot of rings inside Redpanda. So there's no one single, bottleneck where if it breaks, everything breaks, right? So it doesn't have that bottleneck. So all the petitions elect its own leader and then, just figure things out. So that's how independent each one of the petition works. So in terms of that, so we get a better, failover rate and all that kind of stuff, right? Other than that, I think we also have a lot better communications between like each node. So we know we prioritize each petitions. Like, hey, if your petition, like if in this node has too much petition, we'll automatically, kind of figure out which one is the less busier node, and we'll kind of rebalance everything.
So you rebalance who is currently managing that partition,
right?
Dynamically.
Yes.
Okay. And is that transparent to the user? I don't see that on the consumer producer side.
Yeah, you don't see that. Everything is done internally within the broker itself, and we'll just tell the consumer, hey, the leader has changed, and this is where you're going to get it and all that kind of stuff. It's very similar to things. But I think Kafka is a little unique in that terms because Kafka client itself is very smart. Kafka client itself does a lot of, determining where do I go and how sticky am I and kind of figure it out. The broker itself is dumber compared to the messaging queue we used to have, right? It just does all the. I know it's doing a lot, but it's just doing the replication and all that. So I think a lot of it becomes the job of the client. So the client needs to know a lot in order to kind of speak to that. So we have to also obey that protocol from the client so we can kind of fit into all different versions of that. Of course, we have a limit, right? So some of the less efficient consumers, algorithm will probably just not do that anymore. We'll just say we only support to this versions of client, and it's good for the users as well because it's more efficient. So we'll do that. So we'll kind of work with that client code in order to get better balancing for both consumers, leaders, and data partitioning.
Okay. Surely that's going to, once you switch the partition leader, at some point that's got to trigger a consumer group rebalance that the client does see, though.
Yes. So we'll prioritize that.
The cause and the management of it is automatic, but the client will the programmer doesn't have to change anything, but the client will do some work in cooperation with that rebalance.
Yes, and then we kind of honor that, right? So like the sticky corporate way of doing things, we prefer to kind of stick to where it was before, so there's less movement and all that. We'll do the same. So that's why we have priorities, right? So we'll shift the one that has less consumers, and you can kind of see which one is. We prioritize them in the. I can kind of send you a link of like how we prioritize it, but there's a lot of like logics you need to kind of figure out, like the CPU, the bandwidth, and then how many consumers, and like all that, and then how fast is like how, and then also IOPS and all that, and it becomes a determined factor, and then we can kind of rebalance everything.
And do you do things like watch how long that problem lasts before you do something about it?
Yes, there's a timeout thing as well,
okay.
right?
Yeah. It's interesting. That makes me think. So the way consumer group rebalancing used to work was stop the world, rebalance everyone, start again.
Right.
And it wasn't too long ago that they changed that to only if you're being reassigned, you have to stop your work and give up and come back. Which I'm assuming You do, but that raises the question, which version of the Kafka protocol are you actually following, and how far back do you go?
Yeah, I can't really tell. I don't have a vivid number like where we go, but I think we actually try to match the most current one. Actually, we bring up some of, I think from, I've heard that from one of our engineer. He actually started talking to the like the client community, like talking about ideas of, how can it be more efficient from the client side in order to have that communication. So he actually does work with the client groups to actually get that thing working as well. So yeah.
But so you're tracking the latest version of the Kafka protocol, are you saying?
Yes, we do. Yes.
You must have a fairly large team just dedicated to doing that. That's enough work in itself, right?
I don't know exactly how many people were there, but I know there's not too many.
Okay. I mean, how large is the company? Just give me an idea from that size.
I think we're about 200-ish.
200, okay.
Yeah.
In Silicon
We're
Valley
growing,
size,
so
that's fairly
I don't
modest.
I don't know how many exactly because we're still growing, we're still hiring and all that. So I don't think we have a lot of people right now.
Okay. So if you're growing, where are you going with this? You've
Of
mentioned
course.
WASM. Yeah. Where
So
else are you
yes,
going?
WASM and then serverless, of course, in order to support all the customers. So we also have managed Kafka, of course, that's already there. Managed Redpanda services, that's already there. BYOC, and then we have now bringing on serverless, and then WASM, and then we're also working on this. So we already have tier storage, which is I think Kafka doesn't have it, but Confluent already has it, which is kind of offload the non-retain data offloaded to the object store, right? So
Yeah,
you don't have to.
keep the hot stuff in SSD, and the rest you push to S3 or whatever. Yeah.
Yeah, exactly. Yes. So we do that, and then we also added something called read remote replica, which is you can rehydrate your an entire different cluster. So you have your operational cluster here. I think a lot of the data engineers loves that, that implementation was they can still have the operational side of the house of working with the current clusters. But when they're trying to, backfill all the jobs that they need to run, say they have to kind of go back to 3 days ago, 4 days ago to run a long, large and process a large streaming data, what they can do is they can have a separate cluster which is rehydrated with historical data, and they can kind of use that as the part where they can kind of use that to run their process and their jobs there. So it's called remote replica, which is kind of reusing that, S3 object store that we have to store historical data as well.
Oh, right. So it's not quite the same as something like cluster linking, where you
Uh,
join one cluster to another. Are you more like reading the same object storage for a different cluster?
exactly. Yeah. So
Okay,
that's
that's
more
interesting.
for data. I think data engineers use that a lot more. For example, for the microservices user, this is a lot less because I think for them this is just a traffic control centers where they can relay their messages. But for backend, data engineers, they need a lot of historical data that wasn't stored somewhere or that wasn't stored into databases or that is in data lake. But it's actually easier to kind of see the flow of how the data was coming in, the logic of data and like the historical like timestamps of it, that they like to see that way. So they'll process it from there.
I'm curious about that. Why would you not just create a new consumer going further back on the existing cluster?
Because that's going to sacrifice the performance of your current running brokers, right? You can also do that, but then you're going to rehydrate a lot of the data from your historical data into your current broker. So you're sacrificing part of your broker
Oh.
performances.
So once you're in the tiered storage world, you're going to mess up that hot cache section.
Yeah, exactly. Right. And it's
Yeah,
going
I
to
can see why
sacrifice.
that'd be an issue. Yeah, yeah.
Yeah.
Okay.
And then the huge, I think what I see the company right now is a split between operational side of the house and then the analytics side of the house. I see a lot of I came from the operational side, transactional side, where everybody's doing microservices. It's everything's
Yeah.
containerized, and you got Kafka underneath the hood and all that. But then same time, I see the new side of the house where analytics, where they're just picking up the streaming side of the story. They were starting to learn Kafka, and they used to use a lot of Spark. They used a lot of like MapReduce, that kind of thing. And they're starting to kind of get the data. They're starting to get real-time data, because now for machine learning, they need to kind of produce a lot of data sets. And the data sets are the way the data science requests them were kind of random. I don't know, like depends on how they implement it, but sometimes they have to go way back for a lot of data. And they need that. And also they want to have like real-time machine learning. I think a lot of them were adopting that real-time machine learning. So they're trying to get that thing hooked up. And I think from this side, there's a huge gap compared to where operational people were so confident, like they know how to use the Kafka thing already. But here, I think they're still doing that.
Yeah. You kind of want to isolate yourself when you're massively experimenting, right?
Right, exactly.
Yeah, I can see that. Okay, and how about you? Where as head of DevRel for Redpanda, where are you taking things into the future personally?
So I'm still, when you say DevRel for a startup company, I think most of the startup company doesn't know what DevRel is. So I think I'm doing a lot of technical marketing instead of doing a lot of DevRel stuff, because there's just this huge gap of things that needs to be filled in order to, do a lot of, before I can go off and start speaking. Because once I do that, nobody's creating content, and you actually need people creating technical content that speaks to the developers and the people that knows the technical stuff, instead of like really fluffy, marketing messages, right? So I'm doing a lot more of that, and I want to grow the educational side of the story, because I feel like there's not enough educational content for Redpanda, for instance, teaching people how typical works, and teaching people what does that mean in order to maintain a Redpanda cluster. And I wanted to kind of make that easier and I think there's not enough course. There's a lot of course for Java developers already for using Kafka, but not enough for other languages. So I want to like build on top of that. So maybe build a better educational content for my users as well.
Yeah, I can totally see that and agree with it. But that spreads you very thin.
Yes. We do have 2 people like in our team, but it's still we still need a lot of things to do.
Yeah, there's always more education to do. Okay, final question, and this is really like 2 final questions. If I want to go and use it, there are 2 things I need to know. The first is, what's the license for Redpanda?
So it's actually you can use it if you don't use it in production. So what is it? I forgot the name. Like BSL.
BDL.
BDL, BSL. I forgot. Like sorry,
I forget which.
Yeah, I can always forget about the terms, but yes, but I think it is free for use if you use for development, and if you're using it for production, that's when you kind of needed to reach out to us. And there are community features you can use freely in production. There were just a few enterprise paid features that you need to reach out to us in order to kind of get it started. So, for instance, the auto balancing part where I mentioned. And then the tier storage, the read remote replica, which is the part you kind of have to, work with the license Redpanda cluster.
Okay. And if I want to get started, what do I do next?
What you need to do is go to our website, and then there's a getting started with Redpanda. That's the easiest part. And then we also have a university that teaches you how to get started with Redpanda.
Oh, very nice. Do you get a plaque?
Yes. You get a plaque and a certification.
Well, Dean Lin, I will leave you to go off and write more courses at that point. Thank you very much for talking to us.
Thank you.
Christina, thank you very much. I'm going to go and check out Redpanda. I'm going to kick the tires and see how similar it is in practice. And one thing I'm definitely going to check out is the GUI. I hear whispers on the grapevine that that's how certain people from the Kafka world have got hooked in. So let's see what it's like. If you want to check it out, as always, I'll put links in the show notes. If you've enjoyed this episode, as always, please do take the time to like it and share it and rate it and whatever. And click subscribe if you haven't already to catch next week's episode. But until next week's episode, I've been your host, Chris Jenkins. This has been Developer Voices with Christina Lin. Thanks for listening.